Theorem 23. If the diagonals of a quadrilateral bisect each other, it is a parallelogram. This is the converse of Theorem 20, saying that the diagonals of a parallelogram bisect each other. Now, if we maybe in the future get to a problem where we get diagonals bisecting each other, we can therefore conclude that it is a parallelogram. But right here we have to prove it to make sure it is true. So we have our given quad ABCD with diagonals ACBD bisecting each other, which I'm going to make our markings here. If AC is bisected, that means AO is equal to CO and DO is equal to BO. And so now we are given that the diagonals bisect each other. We are now going to prove that this is a parallelogram. It's already quadrilateral. Let's prove that it's a parallelogram. Step number 2, I'm going to say that AO equals CO, DO equals BO. We've stated it, or we've just made our markings on our picture, but we have to state it in our proof. Very important. Don't ever oversight. When it comes to proofs and you're a beginner, usually you have to write down every single thing. I don't do very rigorous proofs. And I think a lot of you may see that. I'm not writing down every single thing that a very rigorous kind of geometry would make you. Example, if in some other theorems I draw auxiliary lines and it's a transversal of parallel lines, I don't state that it's a transversal. By inspection and a very kind of laid back kind of proof, it's pretty obvious that's a transversal. There are professors and there's a lot of teachers and courses that make you write down just about every single thing. And so, but even in these basic proofs that I'm doing, you don't want to overthink some things. Yes, I do understand that it's sometimes confusing. Why do I have to say that AO equals CO and DO equals BO if it pretty much tells us that that's true in the given? They pretty much tell us, but they do not tell us. They just say that the diagonals, they bisect each other. So to make it crystal clear, we want to say the exact letters, the exact line segments that are equal to each other. All right, and the reason we can say that those line segments equal each other is the definition of segment bisectors. All right, number 3, we can say that angle 1 equals angle 2, and angle 3 equals angle 4. A simple idea in geometry: vertical angles are equal to each other. And so vertical angles are formed when two straight lines intersect, and the vertical angles are the opposite, pretty much the non-adjacent angles in those intersecting lines. And so we've already proved this earlier, and we're not going to talk about it anymore, but we know that vertical angles are equal. When two straight lines form vertical angles, those vertical angles formed, those angles that are formed are equal. Okay, step number 4. We can say that triangle DOC is congruent to triangle BOA. And this is by side, angle, side. Let's zoom on in here. We just stated that triangle DOC is congruent to BOA by side, angle, side. We said we can say that because we already have two sides of one triangle equal respectively to two sides of another triangle. And these are the two triangles. We've got the two sides equal respectively to the two sides of another. And then we just stated that the vertical angles are equal. We just stated that this angle is equal to that angle. Angle 3 equals angle 4. So those two triangles are congruent. We could also state, and might as well, that triangle DOA is congruent to triangle BOC for the same reason. we can say that this angle is equal to that angle, and the two sides of one are equal respectively to two sides of the other triangle. All right, step 5. We can now say that DC equals BA and that AD equals CB. Because of CPCTE, we have congruent triangles, and so their corresponding parts are equal. And then number 6, we can say that ABCD is a parallelogram because opposite sides of a parallelogram are equal. There it is. Theorem 23, if the diagonals of a quadrilateral bisect each other, it indeed is a parallelogram.